let's have another example given the data below, wherein we have to find the divided difference between x sub 0 and then x sub 1, and then the divided difference between x sub 0 and then x sub 2. So we have to calculate p sub 1 and then p sub 2 with the following values, and then using the formula that we had done earlier, using the divided difference table, applying the formulas in finding the divided difference coefficients, we'll have this. Take note that the divided difference between x sub 0 and then x sub 1 is equal to p sub 1 of x. So using this formula and then substituting the given values, we will arrive to this interpolating polynomial, which will be needed to get the approximated value of the given polynomial. Therefore, p sub 1 of 0.15 is equal to 0.22. Between x sub 0 and then x sub 2, we'll have p sub 2 of x. So again, using the formula and then substituting the given values, we'll arrive to this interpolating polynomial, which will be needed for us to be able to approximate the given polynomial. And thus, it will result to p sub 2 of 0.15 is equal to 0.2175. And now let us discuss the last topic about interpolating polynomial at an equally spaced method, and that is Eiken's interpolation method. But before that, I will give a brief information about Eiken. His complete name is Alexander Craig Eiken. He studied PhD at the University of Edinburgh. He was one of the best mental calculators, and he had a prodigious memory. He knew the first 1,000 digits of pi, 96 recurring digits of 1/97, and memorized the INIT in high school. He worked in statistics, numerical analysis, and algebra. He is also one of the New Zealand's greatest mathematicians. In his dissertation, Smoothing of Data, that is so impressive, he was awarded a DSc in 1926, and he became the president of EMS in 1931. He was also an excellent musician and a champion athlete in his younger days. Let us define now Eiken interpolation. It is known to be the higher order of Newton's divided difference formula. It yields systematically and successively better in interpolation polynomials that correspond successively high-order truncation of Newton's divided difference formula. Its major advantage is that the accuracy may be gauged by comparing successive steps. In the case of Newton's divided difference formula as the rule, the points x sub 0, x sub 1, x sub 2 are ordered such that x sub 0 minus x, x sub 1 minus x sub 2 minus x form a sequence with increasing magnitude. So the definition emphasizes its relationship to the Newton's formula that does not involve at all the dividing difference. It also computes a point on the interpolating polynomial through a sequence of repeated linear interpolations diagonally. Okay. This is the formula in finding the divided cross multiplication given 2 points, wherein this will result to this equation, and then after which will result to the final equation, which is the formula in finding the divided cross multiplication given 2 points. Let's have an example wherein we have to find the approximated value at x is equal to 2 of the points 1, negative 6, 3, positive 4, 0, 1, 6, and 169, and then 10 and 921. And since the first step is to get the difference between x sub k and then the given value of x, we have 1 minus 2 is equal to negative 1. And then 3 minus 2 is equal to positive 1. 0 minus 2 would be equal to negative 2. And then 6 minus 2 is positive 4. And then get the difference between 10 and then positive 2, which will result to positive 8. and then we will get the first divided cross multiplication given 2 points, the second divided cross multiplication given 3 points, the third divided cross multiplication given 4 points, and then so on and so forth. So this is the formula in finding the first divided cross multiplication given 2 points. And then we just need to substitute the given values in the formula, and this will result to -1. So this will be the formula. Again, applying the formula and then substituting the given values in the equation, that would result to -13. Likewise, if we still apply, this is the formula in finding the divided cross multiplication given 2 points. So we will just substitute the given values there, and we will arrive to -1. And to complete the set of values in the first divided cross multiplication given 2 points, we will just apply the same formula and then the same method, and that will result to -13, +29, and then +97. That completes the first set of the divided cross multiplication given 2 points. And then we have this formula in finding the first or the second divided cross multiplication given 3 points. So again, applying the formula, we'll have -5. And then to complete the second divided cross multiplication given 3 points, we'll have -11. And then -15. And then, this is now the formula in finding the third divided cross multiplication given 4 points. So again, applying the formula, which will result to -7, and then -7. That completes the third divided cross multiplication given 4 points. And then the last, the divided or the fourth divided difference given 5 points, and then applying again the formula or substituting the given values will result to -7.